Okay, question number B1, which is your second question. This question, the solution for this question will be in YouTube on this Tuesday, which falls on 24th of September 2024. Okay, let us start with this. A body slides with a negligible friction from point A down. Okay, let me increase this font a little bit. It's not so clear. Right. Let me close this. Okay. So a body slides with a negligible friction. Okay. From point A down a smooth curved ramp starting from rest. Okay, so here when I say it is starting from rest, what do you mean by that? It means initial velocity is 0. End of the ramp is at a horizontal at point B. At point B, at this point, end of the ramp is at a height h1 below A at a height h2 from the floor. Okay, this height is h2, this height is h1. Okay, next what happens? On the ramp above, sketched in the shape of the path taken by the body after it leaves the ramp. So after it leaves the ramp, what will be the path of the path? So what happens? Here initial velocity is 0. So as it keeps on coming down, its velocity keeps on increasing. When it comes here, its velocity is much higher. Then it goes like this. All the velocity is in this direction, which means what? It will now perform a projectile motion like this. What kind of projectile is this? This is your horizontal projectile motion. Okay, which means the entire motion is divided into two parts. One part in this way, the other one is very clear horizontal. Okay, now, so this is along the ramp. Don't approximate it to that of a straight ramp like this. This is a curved ramp. Okay, so we need to do it by a different method. Okay, now let us understand what's the question. So the first part is done. We have already drawn what happens over here. So it should actually curve here itself. It should curve here itself. So every part of it should be curving here. See, this is a mistake here I made. Because so most of the point over here, from here to here, it's a horizontal one. That should not happen. Okay, so it should be curving from the very beginning. Right, so that the body will hit the floor at a distance d from point O, given by d is equal to 2 into root of h1 h2. So he is asking you prove that d is equal to so much. Let me say this point is, what is this point? This is A, this is B, this is O. Let me call this point C here. So you need to prove d is equal to 2 root of h1 into h2. This is what you need to do. h1 is this height and h2 is the other height. Now how do we do it? Now you see, why does the object start from here and to come here? Gravity pulls it down. Okay, what is the energy at this point? The energy at this point is nothing but, if I take this as my reference level, I can say this is your mgh1. Okay, what is the energy here? The energy at this point is nothing but half mu square, right? All the potential energy has got converted into kinetic energy. There is no friction here. So therefore, what I can do is I can equate these two energies, right? So I can write half mu square is equal to mgh1, or this m and m goes away. So you can write u square equal to 2gh1. What is this now? This is the horizontal velocity. Horizontal, where I don't write like this, mention it as where u is the horizontal velocity of the projectile during its path from where? From where is it? I already labeled it. Okay, this is B and this is C. From point B to land at C. Okay, we have done this also here. Okay, what is this now? This how did we get? We applied a conservation of energy for the path A to B. We have done this also here. Okay, now when you have, see, now we already learned. Okay, when you have a particle moving with a horizontal velocity and falls over here, now how do you find out the distance? It's quite easier. So what you do is you say that the distance r is equal to ux into t, where ux is the horizontal velocity which is given here, and t is nothing but the time taken by the particle to start from here and to reach here. How do you find the time? If time t is equal to square root of 2h by g, what is h here? H is nothing but h2. So how do you get this one? So if you are already working out some problems on projectile motion, you will get to know. Otherwise also I can help you out doing this. So what you do is you consider this as your y-axis, this is a x-axis, and this is your positive y-axis, this is a negative y-axis. So therefore I can now write, I am now deriving this equation. This equation I am deriving now. Okay, I can now write as minus h2 is equal to, what is the initial velocity of the particle? Y velocity is 0. Okay, so therefore it is 0 into t plus half into, what is the acceleration along the y-axis? It is minus g, and what's the time taken? T square. right? So therefore I can now write minus H2 is equal to minus half gt square, negative goes away. So this implies that T should be equal to, or T square is equal to, this goes upwards, this becomes 2H2 by G, or T should be equal to square root of 2H2 by G. Okay, so you got this value. Now what I am going to do is I am going to substitute this value here. Ux you already know. What is Ux here? From here you can write Ux is equal to a square root of 2gh1. So I will write root of 2gh1 into, for time t, time we have already got square root of 2h2 divided by g. So simplify this, it will now be square root of 2gh1 into 2h2 divided by g. G cancels. So what am I left out? I am left out with this 2 into 2 is 4, which will be 2 into root of h1 into h2. Okay. So though it appears to be very tough, nothing like that. Okay, you should know how to solve this. Okay. I think this is the end for today's problem. Let us look for tomorrow's problem tomorrow. So much more solution. Okay. Thank you.